This is Kimber coming to you from my bedroom floor once again. I've upgraded. I am using my sister this time. I decided to do the question number one that I was going to do my video on, because I actually made a mistake at the very beginning that caused a little bit of a problem before I finally figured it out. So, at the very beginning, I thought that this might have been a hyperbola, because this is negative and this one's positive. However, what I didn't take into account that it's not in the general form, and I need to do that first. So I'm going to first get everything to one side. So 25x, I'm going to do add 16y squared plus 64y minus 36. I'm going to do that to both sides so that I can get it all by itself. Plus 64y minus 36. So both sides. So that gives me 25x squared minus 150x minus 75 plus 16y squared plus 64y minus 111 equals 0. So now I can rearrange this, make this into the general form by making the squared terms be together. It's plus 16y squared minus 150x. Oh, actually, I'm going to take that away because I already have the 75 on the end because I added the two like terms together. So that's actually just a big plus sign right there. 150x plus 64y minus 111 equals O. So question number A was, is this an ellipses, a parabola, or a hyperbola? And, I'm sorry, an ellipse, not an ellipses. And I thought it would have been a hyperbola because AC, when it's less than 0 or negative, or A times C, it's less than 0 or negative, it's a hyperbola. However, once I put it into the regular general form, these two are A and C. So A equals 25, C equals 16. And that changes things and makes AC greater than 0, which makes it into an ellipse instead. And that is why. That's what I'm starting with. Okay, so this is an ellipse from the Conics section. Okay. So now I can just go ahead and take this away because we already know what that is. I'm going to leave this here because I'm going to need it for my next section. So for B, we need to convert this into the vertex form, or the vertex form. So I'm basically going to get plus 111, so just get this out of my way because it's not a part of any of the squareds. But I'm also going to put in like terms together, so I'm going to put these two, I'm going to get another pen for this, pen color, put these two together, and then these two together. Because they are like terms. So 25, can you see that fine?
Yeah.
25x squared minus 150x, okay? And that's going to be added, I'm going to add 16y plus 64y equals 111. So that helps me because I'm going to combine these and I'm going to square the term of these two. So I had to make sure that they were in together so that I could find the perfect squares for each of these. So I'm gonna factor out the common factors. So I'm gonna factor out 25 out of this first one. X squared minus x 6x. I'm gonna leave a little gap because I know I'm gonna be doing the awesome, really cool hack that Mr. Leach taught us, and that is the half and then square the term to complete the square. So y squared plus 4y. Oh, I gotta leave that little gap. This is why I'm using a dry erase. And that one equals, this all equals to 111. Okay? But I'm gonna add more to it after I'm done completing the square because I'm adding stuff to here. I need to add stuff to here. So I'm gonna do the half, which is 3, square it, which is 9. I gotta make sure I add the negative because this has a negative, so this is also gonna have a negative. So that, and then the same goes for this one. So I'm gonna do the half, 2, square, plus 2. Okay, now I gotta make sure, have all these together. I'm going to be adding 225 because I'm multiplying 25 by 9. I need to add it to both sides because I added this to the first side, I need to add it to the second side. I'm gonna do the same for this one, but instead it's just plus 64. Awesome. Now I know that this is a perfect square with negative, which is x minus negative 3, and y minus squared. These are all squared. So 25 x minus 3 squared plus 16 y plus 2 squared equals 400. Good, perfect, nice. Now I need, since I started out with 0, I need to have 1 or 0 on this other side because in the original form it is 1 on this side and then the squared terms over here. So I need to divide 400, divide 400, divide 400. And 25 divided by 400 is actually 16. Perfect. 16 divided by 400 is 25. Lucky me. Thank you, Mr. Leach. And this, of course, is going to be 1. Continue on. I'm going to just write what we have up here. X minus 3 squared plus y plus 2 squared equals 1. And that is the vertex form after I completed the square, and that is the most simplified version of that. Perfect. Now, I should have gotten a cloth for this, but it's fine. I can do C, which is find the center. I know that the center of my ellipses is actually just going to be HK. So with my knowledge of how the form is for the, so I know that the original vertex is actually x minus h squared over a plus y minus k squared over b equals 1. So I know that's the original version. So I know this one's h, this one's k. So my original version, which was x minus 3, so that's, since that's a minus, it's just h is going to equal to 3. And then y plus 2 can also be written as y minus negative 2. And that's going to be my k. That's another mistake that I am very easily, I know I would very easily make if I wasn't doing this correctly. So I know that the center is 3, negative 2. Awesome. Check. Now I can do D. And that was to list whether it was a vertical ellipse or a horizontal ellipse. So what I do know is a vertical ellipse is going to have, is going to be B is greater than A. And a horizontal ellipse is going to be the opposite, which is A is greater than B. And this is, of course, coming from the original, which is, x minus h squared over A plus y minus k squared over B equals 1. It's these two. And they're actually squared. I forgot to do that in the past. So I know that this is going to be, so that 16, so A is equal to the square root of 16, which equals to 4. B is equal to the square root of 25, which equals to 5. So 5, obviously, greater than 4. Don't need to tell you that, but I'm going to tell you anyway. So we know that this is going to be a vertical ellipse. Basically, it's going to look more like a right side oval instead of on its side like that. Okay, perfect. And the major axis, which is going to go through both the foci, the center, and the goes through both the vertices, the foci, and the center, is going to be x equals 3, because we know that the center is 3 minus 2, and we know that it's going to go up and down. So x is going to be where it's going to be. So x equals 3. Perfect. Now I can go on to E, and it's just finding the major vertices. So we know where the major vertices are going to be. And they're going to be at the very tips right here and right here. And we know the center is here. So we know that x equals 3. We want to make sure we know how far it's going up. So we know that this is going to be B, and this is going to be B. And then these are going to be A, these are going to be A, because those are smaller. So we know that whatever the center is going to be, it's going to be H, K plus B, because we're always going to put B here with the K, because we're keeping B's, K's, Y's together, and A, X, and H's together throughout this entire process. And we know that the major vertices are going to be at the very top and the very bottom, and since it's horizontal, it's going to be the B one that we're adding. So we know that, of course, this is going to be 3, and this is going to be -2 plus 5, because we've already figured out that B equals to 5. So that's one major vertices is going to be 3, 3, check. And the other is going to be 3, -2, minus 5, because we're adding and subtracting to either one. And so that's going to be 3, 5, 6, 7, so -7. Check. And then the minor vertices are going to be the exact opposite. Since these are going to be the ones on the smaller end, so it's going to be these two are going to be the minor vertices. Since these two are going to be the minor vertices, instead we're going to do H minus A, or H plus A, H minus A, K. So we're going to go ahead and go 3 plus, and we've already figured out that B equals to 5, but A equals to 4. Make sure we're not, yep. So 3 plus 4, -2, and then 3 minus 4, -2. So we're doing 7, -2 as one of the minor vertices, and -1, -2 as the other minor vertices. Perfect. finding C. So from previous experience, we know that C equals square root of a squared plus b squared, right? And this is if a is greater than b. So instead, since b is greater than a, we are doing, let me make sure, since b is greater than a, we're actually going to do c equals square root of b squared minus a squared. Perfect. So c equals square root of, square root of 5 squared plus, minus 4 squared, which equals 2. Square root of 25 minus 16, which equals to square root of 9, which equals to 3. Perfect. And this can go straight into, so we found C, and go straight into G, which is finding the focus, which is going to be H. Since it's a vertical, again, they're going to be in these areas, so it's going to be Y. So it's going to be K plus C, H, K minus C. Perfect. So we know that H is 3. It's -2 plus 3. And 3, -2 minus 3. So the final verdict for our foci is going to be 3, 1, and 3, -5. Perfect. You doing okay, Kat?
Yeah.
Okay, the other one is to plot. We're going to go ahead and do that at the end. H is going to be at the end just because it's going to require me to use the entire form, and I don't want to erase all that after I'm done because I'm just going to use that to draw my entire thing. So H is going to be at the end. Okay. So I'm going to go on and do I. And it's I is to find y-intercepts and x-intercepts. So I'm going to go ahead and do this in different colors because I'm feeling bored with black. So we're going to use red for the y-intercept. Y-intercept is basically when x equals 0. So we're just going to replace 0 in with the rest of these. Plus, these are over 16, plus y plus 2 squared over 25. Okay, now I'm basically trying to get y by itself. Oh, this also equals 1. I'm basically trying to get y by itself. So first what I'm going to do is I'm going to do all the math up here, and that's going to end up being -3 squared, -3 squared, which makes it 9, so it's 9 over 16. I'm not going to worry about simplifying yet. Plus y plus 2 squared over 25 equals 1. Perfect. And now I can simplify, I believe. 3, 6, 9, 12, 15. Nope, can't simplify that one. So I'm just going to subtract 9, 16 from both sides, subtract 9, 16 from both sides. So y plus 2 squared over 25 equals, and I'm going to go ahead and combine like terms by creating like terms. It's 16 over 16 minus 9 over 16. Okay, and that will be 7 over 16. Because I was going to have to do that anyway. Because I need to multiply each side by 25. And I can just go across, because it's like, multiplying across. So it'll be y plus 2 squared equals 175 over 16. Okay, awesome. So, and then I'm going to square root each side, and we know we need to add the plus or minus, because otherwise we are not going to have the correct terms, because it's going to be 2 of these. And then I need to subtract these, subtract -2. So y equals -2 plus or minus square root of 175 over 16. And we know, so the y-intercepts are going to be 0, -2 plus square root of 175 over 16, and 0, -6 minus 175 over 16. Check. So for the y-intercept, we've got this, but we can simplify that a little bit more. So we can go 0 minus 2 plus 25 times 7 over square root of 16. I'm actually just going to go ahead and replace that because I'm just going to do this part. So we know square root of 25 is 5, square root of 7, because it's not a perfect square, over 4. So the final answer is actually going to be 0 minus 2, or -2, 5 square root of 7 over 4, and 0, -2 plus, or minus 5 square root of 7 over 4. Check and check. Simplified and everything. Okay, now I can move on to the x-intercepts. We know that x is intercepting when y equals 0. So we're going to go ahead and replace y with 0 and then solve for x. The same process that we did with the other one. Okay, so first simplify this part. So x minus 3 is going to be 16 plus, we know it's 2 squared, 4 over 25 equals 1. We're going to subtract 4 over 25 from each side to get this one even more by itself. X minus 3 squared over 16 equals, I'm going to go ahead and do 25 over 25 minus 4 over 25, which is also 21 over 25. Okay, multiply both sides by 16, and that will give me x minus 3 squared equals 336 over 25. Check, check, check. Perfect. Okay. And now we can, of course, square root both sides. So x minus 3 equals plus or minus square root of 336 over 25. Subtract both sides. 1 minus 3, or x equals 3 plus or minus square root of 336 over 25. Okay, perfect. So we can actually simplify that a little bit more. 3 plus 336 over 25. Okay, I'm going to just rewrite that on the top so I can keep track of it. But we're going to simplify that a little bit more. So we know 3 plus or minus. We can put these in their own separate categories, and we know square root of 25 is actually going to just be 5. Now, we know we can actually put these in a little bit tighter category. Okay, pause the video.
Because we want x by itself completely. So we know x equals 3 plus or minus square root of 336 over 25. We can simplify that a little bit more by going x equals 3 plus 16 times 21, and that equals 336. So that one equals 36. 336, and then we already know square root of 5 is 5. Square root of 25 is 5. So square root of 16 is 4, so we get that, and 21, square root of 21 over 5. So this is our final answer. 3 plus 4 square root of 21 over 5, 0 is, and also 3 minus 4 21 over 4 square root of 21 over 5 and 0.
So actually, had a little technical difficulties on my part. So we're actually, I've already drew it out. So what I'm going to do is, I'm just going to go ahead and write down the points that I have written. So first, I've already written down 3, negative 2 is the center, right? And we've already figured that out. Next, it comes the major axis, which is this pink line. It's x equals 3. Okay, perfect. We know the major vertices. 3, 3. This is 3, negative 7. And this is 3, 3. Check, check. We have the two minor vertices. This is, this one is 7, negative 2. And this one is negative 1, negative 2. Perfect. And these are all things that we found previously. We're just plotting everything. We know the foci from finding the C. And we know that one of them is 3, negative 5. And then this one is going to be 3, 1. Perfect. And the tricky part was graphing our x-intercepts, because these are very small little differences. This one is going to be 0, negative 2 plus 5 square root of 7 over 21 for that one. This other y-intercept is going to be 0, negative 2 minus 5 square root of 2, or square root of 7 over 21. That should actually be over 4. Whoops. I knew that. Perfect. Okay. And then the y-intercepts, the x-intercepts, this is 3 minus 4 square root of 21 over 5, 0. And finally, this one right here can be 3 plus 4 square root of 25 over 5, or square root of 21 over 5, 0. And we've got all of our points plotted. We did the swoop, and that is how you do H. Thank you so much for watching.